Hello students, let's discuss the question. In this question we have to check whether 5, minus 2, 6, minus 4 and 7, minus 2 are the vertices of an isosceles triangle. So in an isosceles triangle, any two of the three sides are equal in order to prove that it is an isosceles triangle. So we are having 3 points. Let's say point P is 5, minus 2. Let's say point Q is 6, 4 and let's say point R is 7, minus 2. Let's say this is our triangle. This is the point P, which is 5 minus 2. Let's say this is the point Q, which is 6, 4. And let's say this is the point R, which is 7 minus 2. So we are having these points. In order to prove that it is an isosceles triangle, either of the any condition must be there. One is that if PQ is equals to PR, it may be case, or PQ is equals to QR, or PR is equals to QR. If any one of them satisfied, then we can say that this triangle is a isosceles triangle. So let's calculating the distance PQ. So the distance PQ is given by the formula, which is x2 minus x1 to its whole square plus y2 minus y1 to its whole square. So we are having the point P, which is 5 minus 2, and the point Q is 6, 4. So the point P is, let's say, x1, y1, and this point is x2, y2. So from here we can say that PQ from here is equals to under root of x2. x2 is 6. So 6 minus 5 to its whole square plus 4 minus of minus 2 to its whole square. So this from here is equals to 6 minus 5 is 1. So the 1 square, and 4 plus 2 is 6 to its 6 square. So 1 square is equals to 1 and 6 square is 36. So from here we get the value of the point PQ, which is equals to the under root 36. Now calculating the value of QR. So again QR is given by the formula, that is x2 minus x1 to its whole square plus y2 minus y1 to its whole square over the whole under root. So we are having the point Q, which is 6, 4, and we are having the point R, which is 7, minus 2. So this point Q is x1, y1, and this point R is x2, y2. So plugging the values here, so the value of QR from here become equals to under root of 7 minus 6 to its whole square plus minus 2 minus 4 to its whole square. So this from 7 minus 6 is 1. So 1 square plus minus 4 and minus 2 and minus 4 is minus 6 to minus 6 whole square. That is equals to 1 plus square of 6 is 36. That is equals to under root 37. So we get the value of the QR, which is equals to under root 37. Now in the same way we are going to find the value of the PR. That is again equals to x2 minus x1 to its whole square plus y2 minus y1 to its whole square. So we are having the point P. Point P is 5 minus 2 and the point R is 7 minus 2. This is x1, this is y1, this is x2, this is y2. So the value of the PR from here is x2 minus x1, that is 7 minus 5 to its whole square plus y2 minus 1, that is minus 2 and minus of minus 2 to its whole square. So this from here is equals to 2 to its whole square plus 2 and minus 2 is 0 to 0 square. So from here we get the value of the PR, which is equals to under root 4. So PR from here is equals to 2. So from here we get to know that PQ is equals to under root 37, QR is equals to under root 37 and PR is equals to 2. So from here we can say that PQ is equals to QR. So PQ is equals to PR, which satisfying the condition of the isosceles triangle, that is either of any two sides must be equal. So we can say that the triangle PQR is isosceles. So this is the answer to given question. So students, in order to solve this problem, we use the distance formula. I hope you understood the concept well. Thank you.
Don't forget to like and subscribe.